In this lesson, we are going to apply the laws of transformations to sinusoidal functions. These are the functions that came from our unit circle. The two periodic functions that we will be doing transformations to are sine and cosine. If I draw a quick unit circle here, you must remember that we always start at 0 degrees and we go around the circle clockwise. And you also need to remember that the x-coordinate is the cosine and the y-coordinate is the sine. Now if I start here, my sine starts at 0. And if I go around, my sine rises from 0 to 1. So that's what happens to my sine function. But my cosine function starts at 1 and goes down to 0. So it starts here at 1 and it goes down to 0. You must memorize that a sine function goes up and then down, and then that a cosine function goes down and then up. And when you do a full circle, you've completed a complete cycle, and a full circle is 2 pi radians. So I went up to 1, back to 0, back down to -1, and after a full circle, I'm back where I started, and I can keep going around the circle to develop the sinusoidal function. So that's called the period, which means going around full circle. We can apply transformations to the sinusoidal function so that we can stretch the wave horizontally, vertically, and translate it horizontally and vertically as well, so that it can match a particular set of numbers that are cyclical. So let's get our terminology straight. So for instance, the distance from peak to peak, horizontally speaking, in physics class, you learned that is called wavelength. But in precalculus and calculus, it is called the period of the function. And we like to use a capital letter T to represent period. In this example, the distance from here to here is 5 units wide. So this has a period of 5. Next important thing is to identify what's known as the midline. So you have the top of the wave and the bottom of the wave. If you find the horizontal line that goes through the middle of it, that is called the midline. And the midline is displaced from the x-axis, and the distance to the x-axis is called the displacement to midline. We're going to write that right here on this side right there. This is called the displacement to midline. All right, turn your sheets around so we can write displacement to midline. Displacement just means how far away it is from the x-axis. It is also basically a vertical translation, and we're going to use the letter D to represent that. Go ahead and hit pause and write that down. All right. After the midline has been determined, we can then figure out the amplitude of the function, right? So that's going to be this one right here, amplitude. If the wave represents sound, amplitude would be how loud it is, right? A larger amplitude would be a larger, louder sound. If it's a light wave, the amplitude will represent how bright the light is, okay? And obviously, we're going to use the letter A for that. I'm going to stress something very important. The amplitude is the absolute value of the distance from the midline to the peak or the midline to the trough. It's not the full width of it's not the full width of the wave. It's half the width of the wave. It's how far from the midline you are. In this example, it looks like my amplitude is going to be 2 units. So let's say I want to make a sine function that represents this graph. Well, the sine function has 4 coefficients that are transformations of the sinusoidal function. We have A, which is the amplitude, B, which I'm going to explain, and C later, I'll explain that, and D. I've already talked about A and D. Let's do that first. The amplitude for this one, the distance between midline and highest point, is 2 units. So I'm going to write that my amplitude is 2. Now my period is 5 units. So to get from peak to peak, horizontally speaking, I have to travel 5 units. And no matter which two spots I pick on the wave, they're always going to be 5 units apart from each other. That's called the period. Now, you're going to notice that period is not in my function over here. You have to memorize this formula. The b right here is 2 pi divided, so 2 pi over 5. If I wish, I could say 0.6 pi. And then the displacement of the midline is how far vertically translated my sinusoidal function is from the original. And my midline jumped up 5 units from here to here. So my displacement to midline is 5. So far, my function is h of t equals 2 times sine of 2 pi over 5, parentheses, t plus c, I haven't explained what that is yet, and then the d, which is the vertical translation of 5. This one right here, in my opinion, is the hardest one to figure out. It's called the phase shift. So if you remember, a sinusoidal function starts in the middle, goes up and then goes down and then back up again, right? This function started down here, it goes up and then down. So it's not exactly a sine and it's not exactly a cosine. Something happened to where the wave moved left or right. So the best way to do this is to identify the closest sinusoidal curve to my y-axis. And that's going to be this. I can see here that if I start here, I'm going up and then back to the middle, below, and then back up again. And that orange part right there is my traditional sine wave. So what is the phase shift? Well, the phase shift is how far away this is from my y-axis. That's called the phase shift. And that's a value of c. But because my sinusoidal function moved to the right, I have to remember that my horizontal translation is negative. So I'm actually not going to add a number here. I'm going to be adding a negative number. And looking at my graph, it's actually had a point here and it gave me the coordinate. It is 0.75 to the right. Since it moved to the right, that means my phase shift is 0.75 with a negative symbol. And I'm going to add a negative number here, minus 0.75. Now, what if I wanted to do a cosine function? Well, actually, all the numbers are going to stay the same. The amplitude of this graph is still 2. 2 pi over 5 is still going to give me 2 pi over 5. And my displacement of my midline is still 5 units. But a cosine function has a different phase. Now you have to remember that the cosine function starts here, goes down, and then back up again. So a cosine function would be from here to here. Well, its phase would be 2. So for cosine function, its phase is 2. So that would be h of t equals the amplitude 2 times cosine with the new b value based on the period, t minus 2 with a vertical translation, vertical displacement of 5. Now here's the scary thing. On the AP Pre-Cal exam, FRQ number 3 is guaranteed to have a question about where we are forming a sinusoidal function into a scenario. And it's part of the exam where you are not allowed to use the Desmos calculator. My recommendation is that you try to do these problems without Desmos, and then you confirm your results with Desmos.